Welcome, one and all, to Star Talk All Stars, and I'm your all-star host of the evening, Seth Shostak. I'm senior astronomer at the SETI Institute, that's S-E-T-I, almost my name, but that's coincidence. SETI is an acronym, and it stands for the Search for Extraterrestrial Intelligence. In other words, not just life in space, but life that's as clever as you are, or maybe even more so, not to take anything away from your cleverness. So today we're going to talk about a related topic on that score, and in particular, planets. Joining me as my co-host is the very funny Chuck Nice.
Hey, man. How are you, Seth?
I'm just fine, Chuck.
Glad to have you here.
Well,
I'm very interested. The search for extraterrestrial intelligence.
Right.
Because the question is, do we even qualify as that?
Yeah, that's a legitimate question. People ask, is there intelligence inside the Beltway or whatever?
Right.
And we have an operational definition of intelligence, just,
Oh, really?
Yeah, it's simple.
Excellent.
Can you build a radio transmitter? That's
there
it.
you have it.
Can you build a radio transmitter? You're intelligent.
So I'm not intelligent.
Well, listen, nobody at any of the parties I go to is able to do that either.
There you go.
So, and our guest is Jason Wright, and he's an associate professor of astronomy, a member of the Center for Exoplanets and Habitable Worlds, and he works at Penn State University in State College,
Seth.
Pennsylvania. Hey, Jason, how you doing?
I'm doing really well.
Listen,
I'm actually coming to you from Aspen, Colorado, of all places at the moment.
Really? Well, that's just a terrible place. I don't know.
Yeah, I know. It's rough.
You want to be up there.
No, it just sucks to be you, right?
Exactly.
Well, what we want to know from you is what's the status of planets, not around our own sun, but around other suns. And, one of the big news items recently was the discovery of a planet that may end up being the closest planet to us of any of them that aren't in our own solar system, Proxima b. Tell me a little bit about Proxima b.
Right, that is big news. So there's no maybe about it. This planet is definitely the closest planet to the sun that's not orbiting the sun. So the star is called Proxima. We used to always call it Proxima Centauri, which is just Latin for the closest thing in the constellation of the Centaur. But now we know that it's actually the very closest star to the sun anywhere. So its planets really are the closest. So we've been finding planets around other stars in the galaxy for a little over 20 years now. And thanks to space missions like the Kepler Space Telescope, we now know of thousands of planets in the galaxy. And this one, though, is different. It's special because it's really our neighbor. And so we're going to be studying this one in particular because it's right there forever, basically. And we're going to be wondering about it and how to get there and what we can learn about it.
Well, you say it's the closest one. I mean, maybe we ought to give them a number for that. How far away is it?
So stars are really, really far away, to get technical about it. This one being close is a little over 4 light years away. So if you could ride on a light beam, then it would only take you 4 years to get there. So in cosmic terms, they're our neighbors. They're right next door.
Yeah, but I can't ride on a light beam.
Yeah, I would love to ride on a light beam, as a matter of fact. That's going to be the name of my next album, Riding on a Light Beam with Chuck Nice.
That's nice.
So give us an idea of 4 light years. Let's break that down into human terms. How long would it take us to get there?
Well, if we got our best rockets, launched a probe into interstellar space, and we've done this before, so we know we could do that. Let's see, it would take something like 100,000 years to get there, maybe tens of thousands of years if we went really fast.
Yeah, I figure about 100,000 is right. I mean, that's a long time to be eating peanuts off your lap in the middle seat, right? So 75,000 years to get there. Yeah, but it isn't to say that you couldn't get there faster. I mean, if you don't want to go yourself and you just want to send some sort of object, maybe the size of a silver dollar or something like that, to Proxima, you could do that faster, couldn't you?
Well, in principle, right. I mean, this used to be all science fiction, but, recently people have thought hard about this. There's a project called Breakthrough Starshot, which is trying to figure out how to do exactly that. So there's this old idea that if you gave a spaceship a sail, a light sail, so just like a big parachute or something, and then you shot a really powerful laser beam at that parachute, you could accelerate something really fast. And it takes a really powerful laser beam to launch something that could have a person in it. But if you only wanted to launch like a tiny little microchip or something like that, something that weighs less than a raisin, then you would only need a superpowered laser about a square kilometer across.
Well, that's a very
all
modest
you need.
requirement,
I
isn't
know.
it?
I know.
Yeah.
Okay, well, let's get back to those planets if we could, Jason, because, how many planets out there are not just, kind of worthless planets like Neptune, Uranus, those guys, but, might be the kind you'd want to build condos on, or, the kind where you might have oceans, atmospheres, that kind of thing.
Beachfront property is what we're talking about here, Jason.
Right. You want to see water on that thing. Someplace
That's right.
we would want to visit. Well, let's see. There's about 100 billion stars in the Milky Way galaxy, and we now know that most or all of them have planets. Mm-hmm. And so right away we know that we've got many hundreds of billions of planets in the Milky Way galaxy. And some fraction of them, like 10 or 20%, probably have about the temperature that you would need for liquid water. And so we're talking about tens of billions of planets in the Milky Way that could.
Wow.
And we like those planets that might have liquid water because we want to study them and figure out if they do have liquid water or whatever. So yeah, there's a lot of property out there to be claimed.
Look at that.
So I mean, what you're saying, if there are tens of billions of planets that are sort of like the Earth, the possibility that this is the only place where anything interesting is happening, if you think anything interesting is happening here,
right?
Yeah, right. that would make us pretty special, wouldn't it?
If they were right, if none of them had life like life on Earth, yeah, that would make Earth, fantastically unique. 1 in 10 billion or something like that. That would be maybe very surprising.
Well, yeah, but is it possible too? I mean, when you think about, if you were just to play Earth out to its logical conclusion, which is the sun will expand and burn us all to a crisp. Is it possible that has already happened? So there's been life, but it's expired because, of course, that's what all life does at some point. So how would we be able to find that signature, or is that if the idea is to find life first and then you can draw those conclusions?
Well, it's true. There's got to be a lot of planets out there that used to be able to have liquid water on it. And by the way, the term we use, we say that the planet's in what's called the habitable zone.
Right.
That just means it's far enough from its star so that it's not boiling all the water away. But it's close enough to the star that it's not just an ice ball. So when planets are in that habitable zone, that's where we think we'd see this liquid water. And so certainly there are planets that used to be in habitable zones of their stars, but something happened, like the star got big and blew up or burned out, or one of the things stars do, or something might have happened to the planet in its orbit. So when we give that count, we're talking about the number of planets that are in their habitable zones today.
Okay.
But yeah, the history of the galaxy is 10 billion years, and so there's probably a lot of formerly habitable planets out there.
It sounds to me like Chuck is more interested in life that's deceased than in the country. I mean, it's like going to New Jersey and looking for fossils instead of looking for New Jerseyite, right?
Exactly.
Yeah, there are plenty of fossils.
Plenty of fossils.
But, yeah, and some of them are actually New Jerseyites. Okay.
Most of them have been buried by irreputable forces, I'll just say.
Jason, I've got to ask you, because you're really responsible for this idea being promulgated about a star that has the lovely name KI6 8462852. All right, never mind the name.
Say that name again, please.
KIC 8462852, but I may have gotten it wrong.
How can you remember that stuff? I can never remember that.
It just falls off the tongue, actually, I find. But I call it Bob, whatever.
That's very cool.
So this is a star. I mean, it's not very close to us, but it's very unusual. And there was a really an interesting find about it, but you can tell me about that.
Sure. Well, the Kepler spacecraft was looking for planets around other stars. And to do that, it looked at 100,000 stars. And most of these aren't nearby. They're not like Proxima, just 4 light years away or something. They're more like 400 light years away. And it was watching their brightnesses extremely carefully, just in case a planet, maybe like Earth, passed in front as it went around the star, passed in front of the star and made it a little bit dimmer. And so it found thousands of planets like that. It also found lots of stars misbehaving, getting brighter and dimmer for other reasons. But there was one that was just totally unlike all the other. It started to get dimmer, as if there was a planet going in front of it or something. But then instead of getting just maybe 1% dimmer, because there's a planet like Jupiter around it, it just kept getting dimmer. Oh, and over the course of days, it got like 20% dimmer than it had ever been before. And then all of a sudden, over a few more days, it got bright again. It went back to normal. And stuff like this kept happening. It kept having these strange dimming events as if very large amounts of stuff was between us and the star. This stuff has to be much bigger than something like Jupiter. And whatever it wasn't round like a planet or like another star. And so it just had all the astronomers completely baffled about what was going on.
Well, we don't have too much time, but tell me, what are the possibilities? I mean, a star getting dim like that, it's unprecedented. Could it be alien handiwork?
So, yeah, there's a lot of possibilities. We've been scratching our heads looking for lots of natural explanations. But one thing that I noticed is that there was a guy named Luke Arnold who published a paper before Kepler launched. And he said, hey, if there are advanced civilizations, they might build giant things in space, maybe to collect lots of energy, like solar panels or something. If that's true, then those pass in front of the star, Kepler would see that happen, and it wouldn't look like a planet. It would look like something we totally didn't understand. So when this star was discovered, I said, hey, this guy Luke Arnold, he said we might see this, and if we do, that we should be on the lookout. It could be solar panels. So could be. We're not out of all of our other ideas, but that one's definitely out there now.
Okay, I got to ask you, this is just the last question, really quick now, Jason. If you're sitting in the local diner there in State College, Pennsylvania, and the guy next to you says, okay, how much are you willing to bet that what we're seeing going on here is the result of a giant alien astro-engineering project, what do you say?
Well, what odds are you giving me?
No,
no, not very much. We see weird things in space all the time. We can talk about other bizarre signals that have come from space and turned out to be not aliens, but something really new and amazing and interesting in and of itself. So I think we've almost certainly found a new weird kind of way stars can get dimmer that we haven't seen before. But I don't know how to put odds on aliens. I presume it's very low.
Well, Jason Wright, we'll be getting back to you, but now it's time to go to Chuck and the Cosmic Queries. These have been culled from the best questions on the internet about this subject and maybe others.
Yes, exactly. Our listeners are extremely curious, as a lot, and they have all from Facebook and Twitter and every station where you find Star Talk. They have sent us some queries for you guys to tackle. So you don't know what they are, but it doesn't make a difference. It's not about stumping you. It's just about if there is an answer, I'm sure you'll have it.
I'm glad you said that.
Yeah. So let's jump right into it. Let's start off with a Patreon patron question. And Patreon is a place where people support Star Talk and monetarily. And if they do so, we give them first crack at asking us a cosmic query. Just a little perk of buying our love and affection. So this is from Keela Silvis from Patreon, and she says, "I'm Keela Silvis from Minnesota, and my aunt, Dr. Patty Boyd from Goddard, helped me with this particular question for exoplanets." Do you guys know Dr. Patty Boyd, either one of you, gentlemen?
I don't think so.
No?
Well, yeah, she may be working under a pseudonym.
Is it a pseudonym? Yes, exactly. Yes, it's that's her stripper name,
yeah.
Dr. Patty Boyd. She says, besides radio waves, what signs is humanity giving off to other stars that Earth possesses intelligent life? So aside from the actual signals that we are shooting out into space, is there any other indication from somebody who's looking at us from 4 light years away to say, wow, there might be some intelligent life on this little rock from the sun?
I have to say it hasn't impressed them enough for them to send their interstellar battle wagons to Earth, so there's at least that. I'll let Jason start. What do you think is the answer to that, Jason?
Well, yeah, there's a few ways that you might notice that we were here. One of my favorites is that our large telescopes often shoot big laser beams into space to try and correct for the Earth's atmosphere. We create little artificial stars in our atmosphere and then deform the mirrors of our telescopes to compensate for the blurring effects of the atmosphere. So what that means is we're always shooting these lasers off into space. And so if we shot one at another planet, they might notice the laser. It's pretty weak, but it's conceivable.
But it's only a couple of directions, right? They have to be in the right place.
Yeah. They'd have to be right along. We'd have to be intentionally pointing our telescope at them.
So that
presumably for some other reason.
That would be one way. That would be kind of like the old movies where the person would use a mirror.
Yeah,
they're lost at sea, and the plane says, What's that down there? I think I see something.
It was always cowboys trying to signal that the Indians were afoot. That's what I saw.
Yeah.
Although,
that was back before they invented sound.
In movies, when you're standing there and suddenly that little laser beam appears on your chest, it's usually not a good sign. So maybe we shouldn't be doing that.
Well, I'll tell you, that's one way. There are other things, Chuck. I mean,
Definitely.
for example, if you use hairspray, it doesn't look like you use hairspray, but if you wouldn't...
I use mousse.
Okay.
Anyone knows me?
Yeah, well, in the old days, hairspray had these chlorofluorocarbons, and that they kind of changed the contents of the atmosphere, right? You remember the ozone hole and all that stuff.
The big hole in the ozone.
If they had a big enough telescope, it didn't have to be a really big telescope, but maybe they could find that in the atmosphere. Hey, what do you think, Zork? That doesn't look natural, so maybe that would be a thing. And, of course, if they had a really big telescope, I mean, you're talking about telescopes the size of downtown Baltimore or something. If you had a telescope really big, maybe you could see things like freeway interchanges and so forth. Or, and you can work this out, actually, the lights from New York City. You could pick up that light. You'd see, gee, it's awfully close to this. It's a sodium-based light, right? All that orange light.
Right.
Lamps. We're getting rid of those now, but for a long time. And maybe you could do that. It would take really big instruments. The easiest thing, pick up the radars, the television, the FM radio.
So really, it's more the signals than anything else.
I think so. I think that's a point, because that means that since we've only been doing that since the Second World War, really,
right?
Probably nobody knows we're here. So those people who feel they're being abducted, you got to ask, how come they came now?
Mm-hmm. Right.
Yeah.
So now, in addition to that, does that mean that the signals that we have, however weak, like our just regular television and our regular radio, does that escape and go out as well? I mean, would somebody, let's say if they had the right listening equipment, be able to pick up a broadcast from 1930? It's just like, good evening, ladies and gentlemen, on Ships at Sea. Would they pick that up as well?
Well, I don't know how they'd feel about the content, but they wouldn't actually be able to pick it up, because AM radio is refracted by the ionosphere. That sounds kind of techie, but what it means is it bounces around the Earth. In fact, that's why you can pick up a Chicago station here on the East Coast or whatever. So it has advantages, but it means that all those early radio signals didn't make it. All right, well, we're going to take a short break, but we'll be back shortly answering more of your cosmic queries right here on Star Talk.
Would you like to listen to Neil deGrasse Tyson explain black holes or gravitational waves? Want to hear Bill Nye talk about climate change or GMOs? Did you know that you can search the entire Star Talk podcast network by subject or host or guest? It's easy. Just head on over to www.startalkradio.net and search for pretty much any scientific subject in the universe, and it's likely we've got something to say about it. Or as I like to say, if it's out there, we've got it in here. Did you like what I did there? Oh my God, I'm rhyming. I can't stop myself. It's just my timing. Oh, I am so sorry.
Bringing space and science down to Earth. You're listening to Star Talk.
Welcome back to Star Talk All Stars. This week's special edition is a hodgepodge of some of our favorite discussions from the past 2 seasons. Here's more of this week's mashup.
The future of space and the secrets of our planet revealed. This is Star Talk.
And welcome back to Star Talk All Stars. I am Dr. Natalie Starkey. I still have Chuck Nice with me here and Lindy Elkins-Tanton joining us from Arizona.
Yes.
Back to the Cosmic Queries.
Back to the Cosmic Queries. Now, we had to take a little break, but I really did kind of step on a Mongus's question when I interjected my question about the crystals. But let me just give her the proper due.
Okay.
Okay, because here was her actual question. Given the fact that we see life-sustaining water in a few places here in our solar system, how likely is it in other solar systems and galaxies there is water like we have on Earth? So that's the real crux. We got off into the crystals and that whole deal, and which is fascinating.
It is,
but
and it's important
and very important. But please go ahead and finish Anna's question.
Okay, so Lindy. Elsewhere, I think you alluded before that, yes, it's quite likely in the way we think the water in Earth is present, but it was trapped from the beginning, that actually this could happen lots of times elsewhere, all throughout the universe. But have we seen any yet? Have we actually detected it?
There's hints of what's in the atmospheres of exoplanets around stars far away, but only about 12 of them have had any part of their atmosphere measured yet. So that's really an unknown area for us. All we can really do right now, besides work on making those measurements, is learn more about how water is delivered to our planets here in our solar system.
Yeah. That is it. These things are very far away, but I strongly believe there is life elsewhere in the universe, and that because there's water, I think there's just got to be. This place is so huge that, it's unimaginable, but I think it's got to be there.
Now, a couple of years ago, I saw this, I read this article, and there was a discovery, and it was more of a postulate than a discovery. That there may be, when we consider all of the galaxies that we know, and now with the information that we have from the imaging that's coming back, that there might be as many as 600 million planets like Earth.
Wow.
Is that true? And yes, that is true. Cool. So
that is exciting.
That's very exciting. And so with 600 million planets like Earth, what does that do to the likelihood of life and even sentient life?
Yeah, I mean, it's a huge number to even imagine. This is it has to be that there has to be life somewhere else. I'm just absolutely sure of it. When we say they're Earth-like, we should probably explain why they're Earth-like.
Yes.
Because we basically, to get an Earth, we need a planet orbiting a star that it's kind of the right distance away from the star. And it's got to be the right size star, so it's not too hot, not too cold, and that this planet is at the right distance that it could have liquid water on its surface, but it probably needs an atmosphere there to contain it, probably needs a magnetic field to keep it kind of safe, and therefore it's kind of what we call the Goldilocks zone. So this is, the porridge, the oatmeal, whatever you call it here.
Oh, it's porridge.
It's porridge as well. Not too hot, not too cold, just perfect, so that we have the really good conditions like we have on Earth. So these planets exist, and there's a lot of them. It's hard finding them, but they're there just because they're so far away. But yeah, there are a lot of them. I think they've got to contain life. What do you think, Lindy? Is there life out there?
I think that there has to be. I'm with you, but here's the thing that we really don't know. I think we're pretty confident that there are really a lot, hundreds of millions, a billion planets like the Earth. But how long does it take, and how unlikely is it for life to actually start? If we have evidence here on Earth that life only started on Earth one time, even though we had the perfect conditions,
right?
Does that make it less likely? However, I'm with you. There has to be life out there.
But we don't yet know if there isn't life elsewhere in the solar system. I mean, that's the thing. There's not complex life. Right. So we know that because I think we would have seen it by now. But, we're still looking on Mars. There might have been life in the past.
And the other thing that we have to take into consideration, though, is that there could have been life and it could be gone.
Yes, exactly.
Because our solar system will one day be gone.
Yeah.
So there is very possible that another solar system with the same type of conditions as an Earth planet like ours came along, and now we're looking at that system as a part of a black hole somewhere.
Yeah, exactly. So that has,
Okay, all right.
It's a scary thought. That'll be us.
I'm not going to worry about that because I got a feeling that it might happen after I'm gone, and I'm that selfish. Let us move on.
Oh, God.
I'm just laughing at the name. Electronic janitor.
Is this from Twitter?
This is from Twitter.
Is Twitter handle?
At electronic janitor.
Nice.
That's a very cool handle. Something tells me he's an IT guy who really hates his job.
That way.
He wants to know this. Where other than Earth have we positively identified water like we have here on Earth?
Okay, but we have tons of different types of water on Earth. So I guess we've got fresh water, we've got salt water.
Salt water, fresh water.
So yeah, loads of places. It's everywhere.
It's everywhere.
It depends if you want it as liquid or not. But I mean, we think there is liquid in loads of other places. So yeah.
So now here's what I want to know, based upon his question for you and Lindy. Ice seems to be the order of the day because space is really, really cold.
Yeah.
But where does the ice get to be ice? Because it had to be someplace hot and something else before it became that ice on the asteroid or the comet.
Okay.
So where does that happen?
Where does water become the ice water?
Right. Well, what is that? Is that in the formation of something, or what happens to make that happen?
Okay, Lindy, do you want to?
Sure. I can tell you what our best idea is, although I don't think we really understand this process yet. But it looks like when planets are forming, they start out just as a rotating disk of gas and dust around the young star. We see this elsewhere in the universe, even though ours is long gone. And close to the young star, it's too hot for the water to be ice, but further away from the young star, ice is formed because it's cold, even in that early dust and gas disk. And so some of the ice could have been ice from the beginning of the solar system, and it was never melted and then frozen again.
Oh.
There we go.
Look at that.
Primordial. So if we captured a comet, we could drink primordial ice from the origin of the solar system.
So this is like 4.5
that sounds like a party.
years old.
That's a party I want to go to, Lindy, by the way.
I know, that's good.
Yeah.
A little vodka.
Yeah, that's what I'm saying. You know what I mean? Just like, a little Kettle One and primordial ice.
Primordial ice, yeah.
Can I have Kettle One on primordial rocks, please? So that's it. All right.
And you could get the ice made of different types of hydrogen. So if you got like the heavy ice, then you'd get potentially ice cubes that might sink in your drink rather than float.
Nice.
Yeah. This could be fun.
Yo, this is fun. I kind of like it.
Really charge a lot of money for that.
Yeah.
Primordial ice. Yeah, they're lining up right now.
All right, very cool, very cool.
Tripping if you wanna go. I know I made you cry last year when I was on the road.
This is Star Talk.
Welcome to Star Talk All Stars. I'm David Grinspoon, aka Dr. Funky Spoon on Twitter, and I'll be your host today. And I'm joined by my co-host Chuck Nice.
Hey, David. What's up, Dr. Funky Spoon?
How's it going, Chuck?
It's doing well, man. How about you? It's been a little while since we have been together in studio.
It has been a while. It's great to be back with you here in front of the microphones.
Absolutely, my friend.
Yeah, all right. And today on Star Talk All Stars, we're going to do something a little bit different. It's a kind of cosmic queries that we might sort of call, are you smarter than an 8th grader?
I have an answer. No, I am not.
Wouldn't that depend on the 8th grader?
No, in my case, pretty much no is the answer. I'm just going to go with that, and I'm pretty sure I'm going to be right.
Well,
especially the 8th graders that I know.
Well, Chuck, are you funnier than an 8th grader?
Now, that's definite, yes. And whether you're laughing with me or at me,
yeah, that's right.
I'm telling you, that's where I'm a Viking.
That's where you'll make your stand.
That's where I'll make my stand.
Yeah. All right. Well, so what happened here was I sort of had the opportunity to interact with a group of 8th graders from Chula Vista, California.
Okay.
And I've never actually met these kids, but and I'll tell you a little bit later a little bit more about how it was a sort of online virtual connection.
Cool.
But I had the opportunity to talk to them about astrobiology and tell them a little bit about myself and what I do over the interwebs.
Wow.
And then they got back to me with a whole bunch of questions, and they peppered me with these questions, and I was just amazed. I was like, are these really 8th graders, or is somebody pulling my leg?
Yeah. Kind of like, when you go online and you think you're talking to a really sexy woman, but it's really a fat, greasy guy sitting in a basement. And you're like, do these 8th graders have, their own little astrobiological Cyrano de Bergerac working with them? What's going on? I understand.
Or on the internet, how do you know it's not really a smart dog typing at you? You don't even know it's a person.
That's so true. So true.
Yeah. So anyways, but
you were impressed.
No, I was impressed. These are verified 8th graders,
So listen, I guess what we should do right now is jump into the questions from our 8th graders that you had the opportunity to correspond with.
Yeah, these kids are from the Arroyo Vista Charter School in Chula Vista, California, and they really are 8th graders.
Wow. Okay. So here's I'm just going to start at the top, just instead of randomly stabbing about. This is from Christian P. By the way, these are 8th graders. We are not allowed to use their full names because that would be creepy. This is what Christian P. wants to know. Dr. Funky Spoon, what unique aspects does our planet have that differentiate it from other planets, and what other planets have some of these same traits? What allows life to thrive? Very well thought out question, Christian P., and a two-parter there. So what are the aspects of our planet that differentiate it for the purposes of creating life? And then what other planets may have these traits where we can look for perhaps the creation of life?
Yeah, I mean, it's such a good question.
Yeah.
And I'm going to answer it on a, not necessarily on an 8th grade level, because these kids, I've learned, can handle any level. So I'm just going to answer it,
So you mean your answer isn't, excuse me, Christian, duh.
Exactly. Yeah. No,
who doesn't know that, Christian?
Yeah. Come on, Christian.
Come on,
Everybody
Christian.
knows that.
God.
No. It's a great question because the honest answer is it's a little bit of guesswork because we only have one planet with life, and so we won't really know the answer until we find other life and learn what it needs and what we have in common with it. But what we strongly suspect is that the important things about Earth that really allow it to support life have to do with liquid water.
Right.
And that involves a certain climate range. If you have a planet like Mars that's so frozen that you basically can't have liquid water, or a planet like Venus that's so hot that all water would boil instantly, then we think those aren't good places for life. So we're looking for a planet in a certain range of temperatures where you might have liquid water, but also some kind of stable surface environment, and maybe some kind of, Earth also has this kind of geologic activity, this churning interior, what we call plate tectonics, which is just the surface of the Earth sort of squishing around and making geology. And that feeds life. It feeds new nutrients and chemicals. So Earth has this, the geological and the climate conditions that seem to add up to be a good place for
now.
life. For now,
that was a climate joke, people. Thank you.
Yeah,
thank you very much.
If we don't mess it up, right now we've got a great climate. So as far as differentiating from other planets, what we think we need to do is look for other planets with a climate sort of similar to Earth, meaning with liquid water, oceans on the surface. And then also as a, sort of bonus points for a planet, I would say a level of geologic activity like Earth's. If a planet is totally dead, like Mars is, where there's no volcanoes, no earthquakes, to me that makes it less likely to be alive, because you don't have this sort of churning of the interior, which feeds nutrients into the environment for life.
Now, did Mars ever have that at one point? Was there ever a vibrant geological activity happening on Mars?
Yeah. All the signs point to that. You know, we're there with our rovers digging around in the dirt, and we've got our orbiters there, and we keep finding more and more evidence that Mars did indeed have those exact qualities when it was young, both a climate that was warmer and wetter. Mm-hmm. We know that because we see the rivers and all these channels that are dried out now, and also more geologic activity. That Mars is full of volcanoes, but they're sort of dead volcanoes. But at one point, it had that vibrant geological activity. It had that warmer climate. So personally, I'm not that optimistic about finding life on Mars today, but I think it's a great place to go look for fossils. And we're doing that. We're going to be doing that.
And guess what? I mean, if you find fossilized life, you have still found life. I mean, the record of life is still life, right? I mean, it's the proof of life.
Absolutely. If we found fossils on Mars, it would be right up there with, I would argue that, the greatest scientific finding ever. It doesn't have to be a living organism. That would be interesting. Mm-hmm. But in some ways, I like a Mars that's dead today and was alive in the past, because if Mars is dead today, it doesn't restrict what we can go do there ethically. We can go do whatever we want if it's a vacant lot that's not occupied.
Oh, my new hashtag, dump on Mars. There you go. Do whatever you want, baby.
Well,
Mars is dead.
Well,
violate it all you want.
Well, I don't know. Maybe I shouldn't have spoken so loosely so that Chuck could misinterpret me like that. But you know what I mean. It's like if there's a biosphere there, if there's creatures that we could be harming, then we have to tread a little bit more lightly.
Right. Exactly.
I'm not saying we should necessarily go fill up Mars with strip malls and strip clubs and strip mines. Right. But we shouldn't just go strip Mars.
I'm going to say two out of those three things I'm against. So
I don't want to know which two.
Listen, I'm just saying just 2 out of 3, but I'm not going to go there. All right? Hey, I want to talk to you about Star Talk All Access for a moment. When we started our premium subscription service, we thought fans would be more interested in getting to watch video versions of our podcast or enjoy ad-free versions of our show. But it turns out our fans' favorite part of All Access is the new and exclusive original content that we post every week. We're talking about classic videos like me and Neil deGrasse Tyson chilling in his office touching his meteorite. Oh, you heard me. Or the time Neil and Adam Savage hung out in the green room before our show at Comic-Con and talked about Star Wars, Blade Runner, A Space Odyssey, and other really geeky science stuff. Star Talk All Access is your universal hub for all the great Star Talk content you crave, all in one place, including full video of most current episodes, commercial-free audio and video podcasts, live-streamed events, insider-only looks behind the scenes, the ability to watch on Amazon Fire, Apple TV, and Roku, and, of course, new exclusive original content added every week. To get started, visit StarTalkAllAccess.com to subscribe for $4.99 a month with a 2-day free trial. That's StarTalkAllAccess.com. And as a friend of mine says, keep looking up.
This is Star Talk.
There's a billion stars ready to surround you.
Welcome back to Star Talk All Stars. I'm your host, Emily Rice. Co-hosting with me today is Chuck Nice.
Hey.
And we also have in the studio with us today astrophysicist David Kipping.
Hey, greetings to all you Star Talkers out there across the space-time continuum. Thanks so much for having me here. I'm really excited to talk about a matter of really cosmic importance today.
Yes, definitely. So we're talking about exoplanets, especially the TRAPPIST-1 system.
Mm-hmm.
So we talked about a little bit about the star. We talked a little bit about the habitability of these planets. So we did talk about the lifetime of the star.
Right.
Just now we had because it's around an M dwarf star. It's not very different from a sun-like star.
Right.
And so, how different is it? So it's lower mass, it's a smaller radius, it's cooler, right? Yeah. But what does that mean for the exoplanets?
Yeah, so I guess maybe another way of saying that question is like, are there problems for potentially people or life maybe being on those planets?
So these stars live for a very long time because they spend a very long time fusing energy or fusing hydrogen to helium, creating energy. But
I think they're right. I mean, everything happens in slow motion for these stars, right? So actually, the sun settled down into a fairly normal star after it was born within like 100 million years, which is very, very fast. For these M-dwarf stars, it tends to happen like over 1 to 2 billion years. So these planets would have been receiving way more radiation than the Earth received for a very prolonged period of time. So even though these planets are in the habitable zone right now, even, all 3 of them, they would have been being baked. And, maybe that sterilized them for a giga-year. That's a billion years. That's a long time that they were being baked for.
Bad, right? Because we've had life on Earth, not complex life on Earth, but life on Earth has existed for most of the history of the solar system, right? I think it's something like billions of years. Like the life on Earth actually started very, very quickly after the sun was formed.
It happened almost immediately after the heavy bombardment stopped, which is when the Earth was basically pummeled by meteorites and asteroids, and the moon had just formed. And more or less as soon as the Earth became hospitable, life pretty much appears like straight away. So, that's a little bit tantalizing.
Is that a coincidence?
Yeah.
Or that's kind of exciting.
It is. And so what you're saying, though, is after being in a microwave oven for a billion years, the Hot Pocket might be spoiled.
I've been there, right? Billion years in the microwave will do it.
Right. Wow.
But is it just so I study the M dwarfs. I'm going to say that and pitch my research again a little bit because my group studies the brown dwarfs, but we also study some of the lower mass stars. And for a long time, people, I don't want to say didn't care, but kind of didn't care a little bit. It was really when I was applying for grants and, applying for jobs and stuff like that, I had to spin it a little bit. I had to say, well, these stars are important for exoplanets because X, Y, and Z. But now, they really are. Yeah. At first everybody was going after the exoplanets around sun-like stars, which was, the last 20 years or so, but planets around these low-mass stars has only happened for the last 10
these are the
years
sexiest stars right now.
Yeah, and now everybody cares about them. For the longest time, it was somebody's got to study them, I guess. And now it's
you're in the best place right now.
Yeah, it's job security because I want to tell you that we do not understand these stars very well.
That's true.
Right? There's a lot about them that we don't know.
Yeah, speaking of job security, you may not want to tell people that.
In this climate,
exactly. No. Well, should we get into another query?
Yeah.
Because we have Arun Kumar from Facebook, and Arun says this: What are the chances that this system has an asteroid belt like our own? Ooh. Would an asteroid belt even cause sufficient dimming of the host star when observing from 40 light years away? Just speculating, given that the planets orbit so close together, wouldn't that have caused a lot of exchange of material, collisions during the early solar system formation, and thereby creating an asteroid belt? Okay. Arun really knows how to write a question. Or can I say 8? He can write 8 questions. All right. So first, let's talk about the asteroid belt. Is there a possibility?
There's a possibility. We don't know about one yet. The outermost planet discovered in this system actually lives beyond what we call the snow line. So the snow line is the distance from the sun, at least in the solar system, at which water ices and ammonia ices and other ices start to condense out and they become sort of solid grains. The reason why we think that's an important distance is beyond that. That's where you start to form gas giants like Jupiter, like Saturn. So you need to be beyond that distance. Now, what we find is that in the solar system, in between the last rocky planet, Mars, and the first gas giant planet is the snow line, and right bang on there is the asteroid belt.
Is that a coincidence?
So the idea is that, Jupiter was migrating in when it was forming. It was moving around a lot, and it came in and actually probably stopped Mars from growing into a super Earth. Mars probably would have grown into a super Earth was it not for the influence.
What's a super Earth?
A super Earth is add on twice the amount of mass that the Earth has. Just a bigger Earth. And Mars is kind of small.
Earth on steroids.
Yeah, and not only that, but it probably stopped another planet from forming, which was what the asteroid belt may have coalesced to, was it not for the influence of Jupiter migrating in so close. So I think the asteroid belt is closely tied to what Jupiter did early on in the solar system.
Okay.
We don't know about any Jupiters around the star. It's actually very rare that these stars even have Jupiter mass planets. So it's not, my bet would be no, but
can we find out? Do we have the technology to find out if there's an asteroid belt around a star like
That's a good question. It would be super hard right now. I mean, even detecting these planets, which are like 70% the size of the Earth, that's big compared to an asteroid, which is like a few kilometers across.
Right.
Even that's like really, really pushing the Spitzer Space Telescope. It was a tough discovery for Spitzer and K2 to get those. So an asteroid belt, I would be skeptical we could do it with anything we have right now, that's for sure.
It would have to be. So sometimes we find asteroid belts not because they block light from the star, but because they radiate their own heat. But for that to happen, the asteroid belt has to be close enough in that it has to be pretty warm and then re-radiate, which I think for this star is going to be very close in. And we don't find that. It's usually called an infrared excess.
And there's no space, right? I mean, it's a packed planetary system. There's no room.
Yeah, because
every single slot is taken.
Nice.
The H planet outside of the orbit of Mercury relative to the sun, or the H planet is even inside?
I'm not sure exactly spatially, but I know its temperature is something like minus 100 degrees Celsius or something. It's a cold beyond the
relatively cold,
planet.
but still, I think because the star is so cool, everything is still packed really close in there. Actually, this brings up a discussion that I actually saw other astronomers having on Twitter, which is to think about what the planets would look like from other planets.
Oh, yeah.
Like sitting on one planet, like sitting on, say, D or E or one of the habitable ones, and seeing the other planets in your sky. They'd be huge because they're so
close.
Yeah, because they're so close to one another.
Right.
Be bigger than the moon.
Yeah, I think bigger than the moon because everything is so close to one another. But then you'd also have to think about every single one of them is tidally locked. And so you'd see different phases depending on where they are relative to you. And you'd only see them at, you'd have to be sitting at the terminator and see, so you might only be able to see the exterior ones. It's a great, kind of solar system visualization problem to imagine. But there should be sci-fi about this.
And I just have a feeling that we're going to see a black light poster of that at any time now.
Totally. It's totally trippy to think about.
Exactly. Hey, well, listen, Arun, that is a very good question. Thank you so much, my friend. Okay, here we go. Now we get to, this is for those of you who listen to the show often, you know that I really suck at pronouncing names. I wasn't going to end it just there.
Where's this going to go?
It did kind of seem like I was ending it right there. For those of you who listen routinely, you know I really suck. Thank you. Good night.
That's a strong finish.
Exactly. That was my closer. Hey, I'm Chuck Nice. I suck. All right. So I believe this is Tor Balhaj.
Sounds good to me.
Right? Okay. And look at me. I'm looking for approval. Right?
Yeah, that's right.
Here we go. This is what Torre says. If we were to send a radio signal to that planetary system using the radio hardware that we currently have or the most advanced that we currently have, would the signal be powerful enough for a potential alien civilization to detect it, assuming that they are at the same technological level as we?
Yeah, that's a
good question.
That's a really good question. And if it was a directed, purposeful radio signal, without doing the full calculation, which I probably should do, I want to say yes to that. Yeah, but I know for sure that our own leakage. So we produce, just radio waves from television signals and radio shows like
we
used to, but even still, there's still some leakage. We could not detect that if even if it was on the nearest star, Proxima Centauri, Alpha Centauri, we could not detect leakage from the nearest star with our largest arrays right now. Maybe the next generation, the SKA, might be up for it, which is being built right now.
Okay.
But right now, even the nearest star, and this isn't the nearest star.
So the whole idea of an alien civilization picking up our television broadcasts, and that's how they know about our society and who
Really a
we are.
Futurama episode.
Yeah, it's like that's never going to happen.
Well, they could do it if they had much better radio receivers than us. They were building planet-sized radio receivers, then sure, they could detect us. But
okay.
Which is not, I mean, we have planet.
So it's like a Death Star for good. We built a Death Star.
That's no moon.
Yeah, it's an eavesdrop.
It's a radio receiver.
To eavesdrop.
We made that.
That's pretty cool.
But so, but it's not far-fetched to think of a civilization with more technologically advanced systems than ours, right?
Sure.
That's what we're hoping. That's why we push forward. And maybe this other star has had trillions of years. Well, no, it's more billions of years than we've had to push forward.
Right. Yeah.
I don't know. I just want to stay optimistic a little bit.
Oh, super cool.
I'm bummed to hear that they're not listening to our old I Love Lucy shows.
Fascinated by listening to our radio shows,
yeah.
I'm sure.
Yeah, okay. Well, hey. That's a very cool thing. All right. So let's
what else do we have?
Let's move on to Will Nyland. And Will comes to us from...
That sounds like a pseudonym.
Will Nyland.
Very close to Bill Nye, isn't it?
Yeah, almost. Yeah. Coming to us from Facebook. And he says this: if NASA's budget doesn't increase, would NASA have to partner with private companies to co-fund getting us to anywhere we have to go? Is this a door to a new space race? Okay. So, I mean, he's looking at it from both the optimistic and the realistic standpoint. Because, from what I understand, not only is NASA's budget going to be cut under our current administration, but NASA now owes, they have to pay back. No, I'm joking.
I was like, this is news to me.
Oh my gosh.
They're in debt.
I was getting really nervous.
Well, you know what's funny is that the current climate in which we live,
so
and you actually believed it.
Yes, it's so believable. Oh my gosh.
Anything goes these days.
Yeah, it's like,
to be honest.
oh my God, NASA just got a bill. Oh my God, we owe the government money.